On this final question, we have to interpret a graph and we have to do some work with rates of change and estimation. And this comes under the topic of mathematical modelling. So on the first question, we are asked to state the type of relationship that the graph shows. And you really have three options for this course: linear, which would be a straight line; exponential, which would either be continually increasing at a faster and faster rate or decreasing at a slower and slower rate; or quadratic, which would be going down and then going up. Obviously, there are other possibilities. So that is a straight line on the graph, so it is a linear relationship. Now, a linear relationship would have a rate of change, linking the two quantities together. We've got volume and time. So to get the rate at which the can is filled, it's the volume divided by the time. Technically, the change in volume divided by the change in time. In this case, the graph starts at 0. So all we need to see is how much volume corresponded for 1 second. And read it off the graph: 110, and the units have to have the two units, milliliters and seconds. 110 milliliters per second. If that graph did not go through 0 at volume, so if the can started with some liquid in the can, you would work out the gradient of the line, which is vertical change divided by horizontal change. So going on to question 2, we have this estimation question. We are going to have to make some estimations, make some assumptions, take information we've calculated from previous parts of the question and other information given to us, and then do some calculations with this. So let's get the information from earlier, the 330 milliliter can, and the fact that we can fill the can at 110 milliliters per second. So I'm just going to copy that information over, and we're going to need to work out how many cans we should be able to fill in 1 week. You have to think about what's important. So it tells us you can only fill the cans when staff are present. However, it doesn't say anything about number of staff, so we'll just need to say how many hours the staff are present in 1 week. It also tells us the machines can fill 5 cans at the same time. It's slightly unclear what the situation is, whether you've got just one machine filling multiple cans altogether, or whether you have one machine per can. Also, we don't know anything about the staff putting the cans in to the machine and taking them out, so we don't really need to think about how much time that might take. So basically, I'm going to think of this as you have 5 separate machines, and each machine fills 1 can, and basically we just multiply by 5 for the total number we're able to fill. So 5 cans at a time. We can make an assumption of the hours that the workers are available. So I'll say they're present 16 hours a week. So 16 hours a day, but then 6 days a week. A range of possibilities you could assume, which would all be fine, because it is just you have to make your own estimation, your own assumptions to make the estimate. The 16 hours a day I've said because it's I've thought two 8-hour shifts, and then there is no night shift. That could be used for cleaning or maintenance. Also, the company might not want to hire people on contracts where they work night shift, both because it's more expensive, they may not be able to get the workers, also workers more likely to make mistakes or to be injured working at night shift. and possibly the company isn't going to sell all these extra cans if they operate at absolute maximum capacity. And 6 days a week, because we'll say we'll give them a Sunday off. So this isn't the information we need, so now let's calculate whatever we can. So we could start by saying, how long does it take to fill one can? 110 milliliter per second is the fill rate. The can is 330 milliliters, so that is 3 seconds to fill one can. So how many cans could you fill in 1 minute? So 60 seconds in a minute, which means we could fill 20 cans in 1 minute. However, that's only using one machine. If we think of 1 can per machine, so we'll then multiply by 5, and we've used that information with the cans, with the 5 cans at a time, multiply by 5. So 100 cans per minute. Now we just need to multiply by the time available. So 60 minutes in an hour, 16 hours a day, and 6 days a week. Do this on a calculator, or you work it out in your head or on paper. You do have a calculator in the exam. 576,000 cans, and that is our final answer. That is not the only possible answer. I'll show you from the SQA marking scheme. The assumption for the number of hours was anything between 7 and 24 hours a day, and anything from 5 days to 7 days a week. And the range of possible answers you could have got was anything from 210,000 all the way up to 1,008,000 cans in 1 week.